In this video, we are going to tackle the summary of our course, which is the Bridging SRWE, which are the endpoint, security, access control, layer 2 security threats, back address table attack, and VLAN attacks. And now, let's summarize them. In endpoint security, the news media commonly covers attack on enterprise networks. Simply search the internet or latest network attacks to find up-to-date information on current attacks. There are three current attacks, which are the distributed denial of service, or what we call the DOS. Next one is the data breach, which this is an attack in which an organization's data server or host are compromised to steal confidential information. And next is the malware, and the example for malware are the ransomware such as WannaCry and the Trojan horses and many malicious software. Various network security devices are required to protect the network perimeter from outside access. These devices could include the Virtual Private Network or VPN enabled router, a next generation firewall or the NGFW, and the network access control, which is the NAC device. LAN devices such as switches, wireless LAN controllers or the WLCs, and the other access point devices, interconnect endpoints. Most of these devices are susceptible to the LAN related attacks that are covered in, but many attacks can also originate from the inside the network. If an internal host is infiltrated, it can become a starting point for threat actor to gain access to critical system devices, such as servers and sensitive data. Endpoints are hosts, which commonly consist of laptops, desktops, servers, and IP phones, as well as employee-owned devices that are typically referred to as bring your own device or what we call the BYODs. Endpoints are particularly susceptible to malware-related attacks that originate through email or web browsing. These endpoints have typically used traditional host-based security features such as antivirus or anti-malware, host-based firewalls, and host-based intrusion prevention systems or the HIPs. However, today endpoints are best protected by combining of NAC host-based AMP software, an email security appliance or the ESA, and web security appliance, which is WSA. The advanced malware protection, which is the AMP, products include endpoint solutions such as Cisco AMP for endpoints. The Cisco ESA is a device that is designed to monitor simple mail transfer protocol, or what we call the SMTP. The Cisco ESA is constantly updated by the real-time feeds from the Cisco Talos, which detects and correlates threats and solutions by using a worldwide database monitoring system. Cisco Web Security Appliance, or WSA, is a mitigation technology for web-based threats. It helps organizations address the challenges of securing and controlling web traffic. The Cisco WSA combines advanced malware protection, application visibility and control, acceptable use policy controls, and reporting. And in access control, there is an AAA component that stands for authentication, authorization, and accounting. The AAA concept is similar to using a credit card. The credit card identifies who can use it, how much that user can spend, and keeps an account of what items or services the user purchased. The authentication part of the AAA component stores usernames and passwords locally in a network device such as Cisco router. Users authenticate against the local database. The authorization is automatic and does not require users to perform additional steps after the authentication. Authorization governs the users can and cannot do on the network after they are authenticated. Accounting collects and reports usage data. This data can be used for such purposes as auditing or billing. The collected data might include the start and Start connection times, executed demands or commands, number of packets, and number of bytes. A primary use of accounting is to combine it with AEA authentication. The AEA server keeps a detailed log of exactly what the authenticated user does on the service. This includes all exec and configuration commands issued by the user. The log contains numerous data fields including the username, the date and time, and the actual command that was entered by the user. This information is useful when troubleshooting devices. It also provides evidence for when individuals perform malicious acts. And now let's proceed to Layer 2 security threats. Network administrator routinely implement security solutions to protect the elements in Layer 3 up to Layer 7. They use VPNs, firewalls, and IPs devices to protect these elements. However, if Layer 2 is compromised, then all layers above it are also affected. For example, if a threat actor with access point to the internal network captured Layer 2 frames, then all security implemented on the layers above would be useless. Then, security is only strong as the weakest link in the system, and Layer 2 is considered to be that weak link. This because its LANs were traditionally under the administrative control of a single organization. We inherently trusted all persons and devices connected to our LAN. Today, with bring your own device and more sophisticated attacks, our LANs have become more vulnerable to penetration. And here are the layer 2 attacks. First one is the MAC table attacks, next is VLAN attacks, then the HCP attacks, ARP attacks, address spoofing attacks, and lastly is the STP attacks. And when there is an attack, of course, there is a mitigation to prevent the attacks or the attackers. The two attack mitigations are port security, DHCP snooping, dynamic ARP inspection, or what we call the DAI, IP source guard, or IPSE. Then, let's go to the MAC address table attack. MAC address table attack, or there are MAC address table flooding. All MAC tables have fixed size and consequently a switch can run out of resources in which to store MAC addresses. MAC address flooding attacks take advantage of this limitation by bombarding the switch with a fake source MAC address until the switch MAC address table is full. When this occurs, the switch threats the frame as an unknown unicast and begins to flood all incoming traffic out all ports on the same VLAN without referencing the MAC table. These conditions now allows threat actor to capture all of the frames sent from one host to another on the local LAN or local VLAN. Then the next MAC address table attack is the MAC address table attack. Since there are MAC address table attack, of course there will be mitigations too. To mitigate MAC address table overflow attack, network administrator must implement port security. Then let's go to the LAN attacks. A VLAN hopping attack enables traffic from one VLAN to be seen by another VLAN without the aid of a router. In basic VLAN hopping attack, the threat actor configures a host to act like a switch to take advantage of the automatic trunking port feature enabled by the default on most switch ports. There are VLAN double tagging attack, and since they are attack, of course, like what we say in the previous attacks, it will have the mitigation too. The mitigation for VLAN attack is to disable trunking on all access ports, disable auto trunking on trunk leaks so that trunks must be manually enabled. Picture that the native VLAN is only used for trunk links. Then let's talk about DHCP attacks. The starvation attack, DHCP starvation attack, and the DHCP spoofing attack. Then the next one is the ARP attacks. The problem is that an attacker can send the gratuitous ARP message containing a spoof MAC address to a switch, and the switch would update its MAC table accordingly. Then, therefore, any host can claim to the owner of any IP and MAC address combination they choose. Then let's go to the address spoofing attack. MAC address spoofing attacks occur when the threat actors alter the MAC address of their host. Then the STP attack, attackers can make their hosts appear as root bridges, and therefore capture all for the immediate switch domain. For security, mitigate VLAN attacks, mitigate DHCP attacks, mitigate ARP attacks, and mitigate STP attacks. In implement third-party security, an important part of your responsibility as a network professional is to keep the network secure. Most of the time, we only think about security attacks coming from outside the network, but threats can come from within the network as well. This threat can range anywhere from employee innocently adding an Ethernet switch to the corporate network so they can have more ports to malicious attack caused by this disgruntled employee. It is your job to keep the network safe and ensuring the business operations continue uncompromised. So, the example, if the best situation example here is when you have a trader employee who who, who want to sell your data to another businessman. So he will tend to attack your server. Then let's talk about mitigate MAC address table attacks. The simplest and the most effective method to prevent MAC address table overflow attack is to enable port security. Port security limits the number of valid MAC address allowed on a port. It allows an administrator to manually configure MAC addresses for a port or to permit the switch to dynamically learn a limited number of MAC addresses. When a port configured with port security receives a frame, the source MAC address of the frame is compared to the list of secure source MAC addresses that were manually configured or dynamically learned on the port. Then the security aging. Port security aging can be used to set the aging time for static and dynamic secure addresses on a port. Two types of aging are supported per port, which is the absolute. The absolute is the secure addresses on the port are deleted after the specified aging time, and the inactivity, the secure addresses on the port are deleted only if they are inactive for the specified aging time. Using aging to remove secure MAC addresses on a secure port without manually deleting the existing secure MAC addresses. Aging time limits can also be increased to ensure past secure MAC addresses remain, even while new MAC addresses are added. Aging of statically configured secure addresses can be enabled or disabled on a per port basis. Then the port security violation modes. If the MAC address of a device attached to the port differs from the list of secure addresses, then a port violation occurs by default. By default, the port enters the error disabled state. And the violation modes here are shutdown, restrict, and protect. And the port's in error state, when the port is shut down and placed the error disabled state, no traffic is sent or received on that port. So go to the next one, which is the verify port security. After configuring port on switch, check each interface to verify that the port security is set correctly, and check to ensure that the static MAC addresses have been configured correctly. Then let's go to mitigate VLAN attack. As a quick review, a VLAN hopping attack can be launched in one of the three ways: is spoofing the TCP messages from the attacking host to cause the switch to enter the trunking mode. From here, the attacker can send traffic tag with the target VLAN, and the switch then delivers the packets to the destination, and introducing a root switch and enabling trunking. The tracker can then access all the VLANs on the victim switch from the root switch. Another type of VLAN hopping attack is the double tagging or double encapsulated attack. Then to mitigate VLAN attacks, there are steps. disable the DTP or auto-tracking negotiations on non-tracking ports by using the switch port mode access, interface, configuration command, then disable unused ports, and put them in an unused VLAN, then manually enable the trunk link and the trunking port. And the next one is to disable the DTP, auto-trunking negotiation on trunking ports, then set the native VLAN to a VLAN other than VLAN 1. Then let's go to the mitigation of DHCP attacks. DHCP attack. The goal of a DHCP starvation attack is to create the DOS or the denial of service. For connecting client, DHCP starvation attacks require an attack tool such as Gobbler. Recall that DHCP starvation attack can be effectively mitigated by using port security because Gobbler uses a unique source MAC address for each DHCP request sent. However, mitigating DHCP spoofing attacks requires more protection. Gobbler could be configured to use the actual interface MAC address as the source Ethernet address, but specify a different Ethernet MAC address in the DHCP payload. This would render port security ineffective because the source MAC address would be legitimate. Then DHCP spoofing attack can be mitigated by using DHCP snooping on trusted ports. Then DHCP snooping. It does not rely on source MAC addresses. Instead, DHCP snooping determines whether DHCP messages are from an administratively configured trusted or untrusted source. It then filters DHCP messages and rate limits DHCP traffic from untrusted sources. Devices under your admin control or administrative control, such as switches, routers, and servers, are trusted sources. Any device beyond the firewall or outside your network is an untrusted source. In addition, all access ports are generally treated as untrusted sources. Then let's go to the mitigate ARP attacks. Dynamic ARP inspection or DAI. In a typical ARP attack, a threat actor can send unsolicited ARP replies to the other hosts on the subnet with the MAC address of the threat actor and the IP address of the default gateway. To prevent ARP spoofing and the resulting ARP poisoning, a switch must ensure that only valid ARP requests and replies are relayed. The dynamic ARP inspection or DAI requires DHCP snooping and helps prevent ARP attacks by not relaying invalid or gratuitous ARP replies, intercepting all ARP requests and replies, then verifying each intercepted packet for a valid IP to MAC binding, then dropping and logging ARP replies coming from invalid to prevent ARP poisoning. Then error disabling the interface if the configured DAI number of ARP packets is exceeded. Now, let's go to DAI implementation guidelines. To mitigate the chances of ARP spoofing and ARP poisoning, follow these DAI implementation guidelines. First is to enable DHCP snooping globally, and enable your DHCP snooping on selected VLANs. After that, enable DAI on selected VLANs, then configure trusted interfaces for DHCP snooping and ARP inspection. It is generally advisable to configure all access switch ports as untrusted, configure all uplink ports that are connected to other switches as trusted. DAI can also configure to check for both destination or source MAC and IP addresses. The destination MAC, source MAC, or the IP address. Now, let's go to mitigate STP attacks. Port pass and BPDU guard. Recall that network attackers can manipulate the spanning tree protocol or what we call the STP to conduct an attack by spoofing the root bridge and changing the topology of the network to mitigate spanning tree protocol. STP manipulation attacks use port pass and bridge protocol data unit or BPDU guard. Then port pass immediately brings an interface configured as an access or trunk port to the forwarding state from blocking state. bypassing the listening and learning states. And the BPDU guard, it immediately error disables a port that receives a BPDU. Then port pass bypass the STP listening and learning states to minimize the time that access ports must wait for STP to converge. If port pass is enabled in a port connecting to another switch, there is a risk of creating a spanning tree loop. Then that's all. That concludes our chapter 11. And components, LAN WLAN operation, CAPWAP operation. Then channel management, LAN threats, secure WLANs. Then let's talk about benefits of wireless. A wireless LAN or WLAN is a type of wireless network. This is commonly used in homes, offices, and campus environments. Networks must support people who are on the move. People connect using computers, laptops, tablets, and smartphones. There are many different network infrastructure that provides network access, such as wired LANs, service provider networks, and cell phone networks, but it's the WLAN that makes mobility possible within the home and business environments. In business, with a wireless infrastructure in place, there can be a cost savings anytime equipment changes, or when relocating an employee within a building, reorganizing equipment or a lab, or moving to temporary locations or project sites. A wireless infrastructure can adapt to rapidly changing needs and technologies. Type of wireless networks. Wireless networks are based on the 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 Institute of Electrical and Electronics Engineers or IEEE standards, and can be classified broadly into four main types: the WFAN, WLAN, WMAN, and last one is the W1. Wireless technologies. Wireless technology is the unlicensed radio spectrum to send and receive data. The unlicensed spectrum is accessible to anyone who has a wireless router and wireless technology the device they are using. Radio frequencies. All wireless devices operate in the radio waves range and the electromagnetic spectrum (WLAN). Networks operate in the 2.4 GHz frequency band and the 5 GHz band. Wireless LAN devices have transmitter and receivers due to the specific frequencies of the radio waves range as then the WLAN components. Wireless NICs. Wireless deployment requirement a minimum of two devices that have a radio transmitter and a radio receiver tuned to the same radio frequencies. The end devices with wireless NICs and the network device such as wireless router or wireless access point. Wireless home router, the type of infrastructure device that an end device associates and authenticates with wires based on the size and requirement of WLAN. Wireless router is commonly implemented as a small business or residential wireless access device. The wireless router advertises its wireless services by sending beacons containing its shared service set identifier or what we call SSID. Devices wirelessly discover the SSID and attempt to associate and authenticate with it to access the local network and internet. Wireless access points. While range extenders are easy to set up and configure, the best solution would be to install another wireless access points to provide dedicated wireless access to user devices. Wireless clients use their wireless NIC to discover nearby APs or access points, advertising their SSID. Clients then attempt to associate and authenticate with an AP. The WLAN operation. While wireless LANs can accommodate various network topologies, the 802.11 standard identifies two main wireless topology modes: ad hoc mode and infrastructure mode. Then there is tethering is also a mode sometimes used to provide quick wireless access. Then let's talk about the BSS or basic service set that consists of single access point interconnecting all associated wireless clients. Two BSS are shown in some topology. The circles depict the coverage area for the BSS. Then let's talk about extended service set or the ESS. When a single BSS provides sufficient coverage, two or more BSS can be joined through a common distribution system into an ESS. So in an ESS, it is the collaboration of two or more basic service set. Then 802.11 frame structure. Recall that all layer 2 frames consist of header, payload, and frame check sequences section. All 802.11 wireless contains the following fields: frame control, duration, the addresses, and sequence control, payload, and the FCS. Then let's talk about with CSMA with CA. WLANs are half-duplex shared media configurations. Half-duplex means that only one client can transmit or receive at any given moment. Shared media means that wireless clients can all transmit and receive on the same range channel. This creates a problem because a wireless client cannot hear what it is sending, which makes it impossible to detect a collision. To resolve this problem, the WLANs are used carrier sense multiple access collision avoidance. The CSMA with CA. As the method to determine how and when to send data on the network, wireless client does the following. Listen to the channel to see if it decided. Then sends a ready to send message. The access point receives a clear to send message from the access point. If the wireless client does not receive the CTS message, it waits a random amount of time before starting the process. After it receives CTS, it transmits the data. All transmissions are acknowledged if a wireless client does not receive an acknowledgement. It assumes the collision occurred and restarts the process. Wireless client and AP association. For wireless devices to communicate over a network, they must first associate with an access point or wireless router. An important part of 802.11 is covering a WLAN and subsequently connecting to it. Wireless devices complete the following three-stage process: discover a wireless AP, authenticate with access point, associate with access point. Then the CAPOP operation. CAPOP is an IEEE standard protocol that enables CWS to manage multiple APs and WLANs. CAPOP is also responsible for encapsulation and providing of WLAN client traffic between an AP and a WLC. CAPOP is based on LWAP but adds additional security with Datagram Transport Layer Security or the DTLS. CAPOP establishes tunnels on user datagram protocol, which is the UDP ports. CAPOP can separate either over IPv4 or IPv6. A key component of CAPOP is the concept of split media access control or MAC. The CAPOP split MAC concept does all the functions normally performed by individual access points and distribute them between two functional components, which is the AP MAC functions or the WLC MAC functions. Then DTLS encryption. It is a protocol which provides security between the AP and the WLC. It allows them to communicate using encryption and prevents eavesdropping or tampering. Then it is enabled by default to secure the CAPOP control channel, but is disabled by default for the data channel as shown in the CAPOP management and control traffic exchange between an AP and WLC is encrypted and secure by default to provide control plane privacy and prevent man-in-the-middle or MITM attacks. Then let's talk about FlexConnect APS or FlexConnect access points. It is a wireless solution for branch office and remote office deployment. It lets you configure and control access points in branch office from the corporate office through a WAN link without deploying a controller in each office. Then channel management. Wireless LAN devices have transmitter and receivers tuned to specific frequencies of radio waves to communicate. A common practice is for frequency to be allocated as ranges. Such ranges are then split into small ranges called channels. Then best practice for WLAN wireless multiple action. Configure a basic WLAN on the WLC. configure a WPA2 enterprise WLAN on the WLC, then troubleshoot WLAN issues. Then we are going to summarize all of this. Remote workers, small branches office, and home networks often use a small office and home router. These routers are sometimes called an integrated router because they typically include a switch for wired clients, a port for an internet connection, sometimes labeled WAN, and wireless components for wireless client access, shown. The most wireless routers are ready for service out of the box. They are pre-configured to be connected to the network and provide services. For example, the wireless router uses DHCP to automatically provide addressing information to connected devices. However, wireless router default IP address, usernames, and passwords can easily be found on the internet. Just enter the search phrase default wireless router IP address or the default wireless router passwords to see a listing of many websites that provide this information. For example, is the username and password for the wireless router in the figure is admin. Therefore, your first priority should be to change these defaults for security reasons. In small office or home network, one wireless router may be sufficient to provide wireless access to all the clients. However, if you want to extend the range beyond approximately 45 meters indoors and 90 meters outdoors, you can add wireless access points. Then, many routers have an option for configuring quality of service or the what we call QoS. By configuring QoS, you can guarantee that certain traffic types such as voice and videos are prioritized over the traffic that is not as time sensitive. Such as email and web browsing. On some wireless routers, traffic can also be prioritized on specific ports. Wireless routers typically block TCP and UDP ports to prevent unauthorized access in and out of a LAN. However, there are situations when specific ports must be open so that certain programs and applications can communicate with devices on the different networks. Port forwarding is a rule-based method of directing traffic between devices on separate networks. Topology and addressing scheme used for the bridges and in the table, the access point is controller-based AP as opposed to an autonomous AP. Recall that controller-based APs require no initial configuration and are often called lightweight APs, or the what we call LAPs. LAPs use the Lightweight Access Point Protocol or the LWAPP to communicate with the WLAN controller or the WLC. Controller-based APs are useful in situations where many APs are required in the network. As more APs are added, each AP is automatically configured and managed by the WLC. Configuring a wireless LAN controller, which is WLC, is not that much different from configuring a wireless router. The big difference is that WLC controls APs and provides more services and the management capabilities. Most WLC will come with some basic settings and menus that user can quickly access to implement a variety of common configurations. However, as a network administrator, you will typically access the advanced settings. Then, wireless LAN controllers have ports and interfaces. Ports are the sockets for the physical connections to the wired network. They resemble switch ports. Interfaces are virtual. They are created in software and are very similar to VLAN interfaces. In fact, each interface that will carry traffic from the VLAN is configured on the WLC as a different VLAN. The 3504 WLC can support 150 access points and 4096 VLANs. However, it only has 5 physical ports. Then, each WLAN configured on WLC needs its own virtual interface. The WLC has 5 physical ports for data traffic. Each physical port can be configured to support multiple WLANs, each on its own virtual interface. Physical ports can also be aggregated to create high bandwidth links. In the previous topic, we learned about WLAN configuration. Here we will discuss the troubleshooting WLAN issues. Network problems can be simple or complex and can result from combination of hardware, software, and connectivity issues. Technicians must be able to analyze the problem and determine the cause of the error before they can resolve the network issue. This process is called troubleshooting. To assess the problem, determine how many devices of the network are experiencing the problem. If there is a problem with one device on the network, start the troubleshooting process at that device. Of course, if there is a problem with all devices on the network, start the troubleshooting process at the device where all other devices are connected. And the best example there is the router or the switch. Then you should develop a logical and consistent method for diagnosing network problems by eliminating one problem at a time. When the user PC is eliminated as the source of the problem, the physical status of the devices is confirmed. Begin investigating the performance of the AP, then check the power status of the access point. Then let's go to the troubleshooting when the network is slow. To optimize and increase the bandwidth of 802.11 dual band routers or end access points. To improve the range of wireless network, ensure the wireless router or AP location is free of obstruction, such as furniture, fixtures, and tall appliances. This blocks the signal, which shortens the range of the WLAN. If this still does not solve the problem, then a Wi-Fi range extender or deploying the powerline wireless technology may be used. Most wireless routers and APs offer upgradable firmware. Firmware releases may contain fixes for common problems reported by customers as well as security vulnerabilities. You should periodically check the router or access point for updated firmware. In the figure, or in the network administrator is verifying that the firmware is up to date on a Cisco Meraki. Summary: the remote workers, small branches, office and home networks often use a wireless router, which typically includes a switch for wired clients, a port for an internet connection, and wireless components for wireless client access. Most wireless routers are pre-configured to be connected to the network and provide services. Then, the wireless router uses the receipt to automatically provide addressing information to connected devices. Your first priority should be change the username and password of your wireless router. Use your router's interface to complete the basic network and wireless setup. If you want to extend the range beyond approximately 45 meters indoors and 90 meters outdoors, you can add wireless access points. The router will use a process called Network Address Translation or NAT to convert private IPv4 addresses to Internet Routable IPv4 addresses. By configuring QoS, you can guarantee that certain traffic types such as voice and video are prioritized over the